Okay, students, we're going to continue on with what we were talking about today in class. The notes that I gave you as you were leaving were the guidelines for finding limits at infinity of rational functions. And remember that if the degree of the numerator is less than the degree of the denominator, then the limit of a rational function is 0. If the degree of the numerator is equal to the degree of the denominator, then the limit of the rational function is the ratio of the leading coefficients. If the degree of the numerator is greater than the degree of the denominator, then that's when the limit does not exist. So if it's less than, it's 0, if it's equal, it's the ratio, and if it's greater, it does not exist. So now let's use our rules to find the answers to some examples. The first example I have here for you is the limit as x approaches infinity of 5x cubed minus 3x squared plus 10 all over x squared. We need to compare our degrees, top and bottom, and you will see that the degree in the numerator is greater than the degree in the denominator. So in this case, the limit does not exist. In this second example, 5x cubed minus 3x squared plus 10 all over x cubed plus 4x squared, you will see that the degree in the numerator is equal to the degree in the denominator. So this instance is going to be the ratio of the leading coefficients, which is 5 divided by 1, which equals 5. The next example, 5x cubed minus 3x squared plus 10 over 7x to the fourth minus x, the degree in the numerator is less than the degree in the denominator. So this is automatically y equals 0. You need to take a moment to copy these examples. You can pause the video before you move to the next examples. The next example we are going to look at is the limit as x approaches infinity of 2x divided by the radical or square root of x squared plus 3. If you plugged in infinity here, you would get that indeterminate form of infinity divided by infinity. So you know that the first thing we need to try to do is perhaps rewrite our equation. If you are plugging in positive infinity to x squared, infinity squared plus 3 would still give you infinity. So we're going to say that 2x, this equation could also equal 2x divided by the square root of x squared. Now the square root of x squared is x, and x divided by x is positive 2. If you looked at this same idea, but instead of going to positive infinity, we went to negative infinity, let's look at what would happen there. So we have 2 times negative infinity would be negative infinity in the top, and negative infinity times negative infinity in the denominator would be positive infinity plus 3, and the square root of positive infinity, of course, is positive infinity. So this is an indeterminate form, so you cannot do it this way. We need to look at rewriting this problem. But we also know that there's a possibility that here the answer is going to be negative instead of positive as in the last example. So again, if you had negative infinity times negative infinity, that would be a positive infinity plus 3. And the plus 3 is not going to matter that much. So we're going to just make this x squared. And you know that the square root of x squared is x, and 2x divided by x is 2. However, back at this step right here, it's very important that we remember we are plugging in negative infinity. So if you look at 2 times negative infinity over the square root of negative infinity squared, that's going to be a negative infinity in the top and a positive infinity in the bottom. So like I said in the beginning, we've got to pay attention to those signs. So this is actually going to be negative 2. You can use your calculator to help you if you want to look at the graph of these functions. I will take a moment and put that in our calculator. So in y equals, I'm going to put in our function. And we are going to graph this. And you can see that as you go towards positive infinity here, you're getting closer and closer and closer to the number positive 2. As you go towards negative infinity, you're getting closer and closer and closer to the negative 2. So that's why your answer is positive 2 here and negative 2 here. In the next example, we have 8x cubed plus 4 over 12x cubed minus 6x. Using our rules, you see that the degrees are equal to each other, so the answer is going to be the ratio of the leading coefficients. And 8/12, if you divide the top and bottom by 4, reduces to 2/3. The next example, if I plug in negative infinity, 1/2 times negative infinity minus 7 over negative infinity squared. 1/2 times negative infinity is going to give you a negative infinity minus negative infinity squared is going to give you a positive infinity. That's going to be negative infinity minus 0, because remember when there's an infinity in the denominator, we looked at the pattern today in class, that's going to be 0, which initially equals negative infinity, and infinity is a place, that is somewhere that you will be going off to. This is not an actual number. So the limit in this case does not exist. Same idea on the next problem. The limit as x is approaching negative infinity, except we have flip-flopped. So you have 7 over x squared minus 1/2 x. So if we plug in 7 over negative infinity squared minus 1/2 times negative infinity, we're going to get 0. 2 negatives make a positive infinity, but again it simplifies to infinity, and when that happens the limit just does not exist. Here you have the limit as x is approaching negative infinity of the problem negative 3x plus 1 over the square root of x squared plus x. If I were to reduce this, and I'm thinking about going to negative infinity, anything infinity plus 1 or anything, that the positive 1 doesn't really make any difference. And the positive x, if you have a 3 here, negative 3 here, and you add in a 3, that's not going to make that much difference when we're talking about infinity. So we're just going to look at the first terms, and you know that if you take the square root of x squared, that's going to give you an x. So negative 3x divided by x gives you a negative 3. Now let's take this back and look at this step right here. If I have negative 3 times negative infinity divided by the square root of negative infinity squared, let's look at what would happen. I have a negative and a negative, which is a positive, and a negative squared, which is a positive. So this needs to be a positive 3, not a negative. You can also go back and look at the graph to ensure that you are going towards positive 3. So y equals, I'm going to put this graph in here. We're looking at the limit of this function as x approaches negative infinity. So as x is approaching negative infinity and going this direction on our graph, you are, 1, 2, 3, you are indeed getting closer and closer and closer to positive 3 on the y. So that's why the positive 3 works. Now, if you need to rewind, pause, or go back and take any notes, feel free. Remember to take your quiz on Blackboard.